Please subscribe and you can download this code from description below. Title: The Pitfalls of Type Checking in Python. Introduction. Python is a dynamically typed language, which means that variables are not required to have a specific data type. This flexibility is one of Python's strengths, but some developers might consider type checking a bad idea. In this tutorial, we'll explore why type checking in Python is often discouraged and provide code examples to illustrate the issues that can arise. Python's dynamic typing allows variables to change their data type during runtime. For example, you can assign an integer to a variable and later assign a string to the same variable without any explicit type declarations. This flexibility can lead to concise and readable code. While dynamic typing is a powerful feature, type checking in Python can be problematic for the following reasons. Verbosity: explicit type checking can make your code verbose and less readable. This often involves conditional statements to verify data types, leading to cluttered code. Limited polymorphism: type checking can hinder polymorphism, which allows different data types to share a common interface. Python's strength lies in its ability to work with diverse data types seamlessly, which can be lost when you rely on explicit type checks. Reduced flexibility: type checking can make your code less adaptable to changes in requirements. It can hinder the easy substitution of one data type with another, as you need to update type checks everywhere. Instead of relying on type checks, Python encourages a more Pythonic approach. Duck typing: Python follows the principle of duck typing, which means that if an object behaves like a particular type, it is considered that type. Instead of checking the type explicitly, try to use the object's methods and attributes. EAFP: easier to ask for forgiveness than permission. This coding style is encouraged in Python, where you assume that an operation will succeed and handle exceptions if it doesn't. This often results in more concise and readable code. Python 3.5 Plus introduced type hinting, which allows you to provide optional type information to improve code readability and maintainability without enforcing strict type checks. Tools like MyPy can be used to statically check your code for type consistency. Conclusion. While type checking is possible in Python, it is generally considered a bad idea due to its impact on code readability, flexibility, and Pythonic coding principles. Instead, embrace Python's dynamic typing, duck typing, and EAFP approach to write more expressive and maintainable code. Remember that the Pythonic way is to trust that objects will behave correctly, EAFP, and use duck typing to maintain flexibility and readability. Type hints can be a helpful tool for code documentation and maintenance, but they are not meant to impose strict type checking. ChatGPT. Title: Why is type checking in Python considered a bad idea? Introduction. Python is a dynamically typed programming language, which means you don't have to declare variable types explicitly. This flexibility is one of Python's strengths, but it also leads to the debate about whether type checking is a bad idea in Python. In this tutorial, we'll explore some reasons why strict type checking can be counterproductive in Python and provide code examples to illustrate these points. Why strict type checking can be a bad idea in Python. Loss of flexibility. Python's dynamic typing allows you to change variable types on the fly. Enforcing strict type checking can limit your ability to work with different data types and make your code less flexible. It may require more effort to convert and validate data types explicitly. Verbosity. Type checking can lead to verbose and cluttered code, especially in situations where you need to check the types of multiple variables. This can make your code harder to read and maintain. Performance impact. Type checking adds overhead to your code. When you check types explicitly, you may experience a slight decrease in performance. In Python, it's usually better to use the duck typing approach, where you check if an object behaves like a particular type rather than explicitly checking its type. Limited polymorphism. Python supports polymorphism, allowing different objects to be used interchangeably. Enforcing strict type checks can limit the benefits of polymorphism, leading to less reusable and less elegant code. Reduce developer productivity. In Python, you often write code faster because you don't need to spend time specifying types. Strict type checking can slow down your development process and lead to frustration for developers who are accustomed to Python's dynamic typing. Code examples. To illustrate the points above, let's look at some code examples that demonstrate why strict type checking might not be a good idea in Python. Example 1, Flexibility. In the above code, the add function works with both integers and strings. Enforcing strict type checking would make it less flexible and require separate functions for different types. Example 2, Verbosity. In this code, type checking adds verbosity to the function, making it less readable. Example 3, Polymorphism. Python's polymorphism allows us to work with objects based on their behavior rather than their type. In this code, we don't need to explicitly check the type of the shape, we rely on polymorphism to calculate the area correctly. Conclusion. While there may be cases where type checking is necessary in Python, it's generally considered a bad idea due to the language's dynamic nature. Python's flexibility, readability, and developer productivity are key advantages that can be compromised by enforcing strict type checks. In most cases, it's better to embrace Python's dynamic typing and use the duck typing philosophy to write more elegant and maintainable code. ChatGPT